Hey guys, hopefully you're doing well today. I'm hoping that you're having a good week and you're being extra good for Mr. Petenberg today and tomorrow. Very important that you end the quarter strong. So we have one more lesson today, and then tomorrow you have ACC. But please, please, please make sure that you work as hard as you can, because your final ACC grade will go in on Friday. So if you don't have enough scans that week, or if you don't get to 60, you're going to be in major trouble for your quarter grade. So hopefully you're having a good week and you're working really hard. Okay, so we are just going to look again at circles, but know that we don't always have this perfect circle that we have to find areas and circumferences for. Sometimes we have some really weird shapes that we have to find areas and circumferences. So that's the job for today, is how do we find weird shapes, areas, and circumference and things like that. So we're going to go ahead and get started. Let's just do a super quick review. This isn't even on your sheet, but if I had a circle and I had this measurement and said it's 6, raise your hand if you can tell me if that is a radius or a diameter. Hopefully you all said radius. And then if I said, well, what is the diameter of that shape? Raise your hand if you know that. And hopefully you all said 12, because if radius is halfway, diameter is the whole way. So you always have to double your radius to get to a diameter. Okay? And then likewise, if we have another circle and we measure all the way across, and we say that is 5.2. And I say, what is that measurement? Raise your hand if you know if that's a radius or a diameter. Hopefully you said diameter. And if I said, well, then how do I get the radius? Raise your hand if you know that. And to find the radius, hopefully you know it's half of the diameter. So basically, you take the 5.2 and just divide by 2. So half of that would be a 2.6. You have to really feel comfortable today knowing the difference between radius and diameter whenever you do circles. Okay, here's a good example of we don't always have a perfect circle. So we're going to pretend this is a stage, and you can see that's a half a circle, right? If you wanted to paint the stage, how much paint would you need if 1 gallon covers 75 meters squared? So to do that, we obviously don't have a formula for half of a stage or a half of a circle. So we are going to find the area of the entire circle first. So we're just going to pretend that this is a circle right here. And we're going to paint this stage. So basically what we're going to do is color all this in right here. And anytime you cover the inside, that's formula's your area formula. If you're just going around the edge, it'd be circumference, but since we're going inside, it's area. So first thing we're going to write on our paper is the formula we need is A equals pi r squared, because we know that lovely song, pi r squared sounds like area to me. All right, we're going to go ahead and substitute numbers underneath here. So we see our pi, and we know pi is 3.14, so we go ahead and do that. And then this is shoved together, so we know that means time, so we write our time sign in. And next we got to figure out what our radius is. Well, when you look at this full circle and you see that, that's going all the way across, and we know radius is a short word, and that's not a short length, is it? So what they gave us is the diameter, and so we have to figure out the radius. Raise your hand if you can tell me what the radius would be. If you said 7.5, you're correct, because all you do is you take your 15 and divide by 2. So you get 7.5, but don't forget that's just one radius. Our formula says we need to square it, so we have to write it twice. Anytime you square something, you just go ahead and write it twice. So go ahead right now, I'll give you a second here, and I want you to calculate that. And when you calculate that, you're going to get 176 point, it's 625, but remember how we were rounding to the hundredth? So let's go 6.3. But remember when we did the formula, this is formula for an entire circle. We don't want a whole circle. We only want what fraction of the circle, so we only want half of the circle. So does it make sense to you guys that we need half of that amount? So half of 176.63. Anytime you do that in math, guys, anytime you have a fraction of something, this of means times. So it doesn't matter what fraction it is, a third, 3/7, 2/5. Whenever you need like 2/5 of a number, it's 2/5 times a number. So we're going to go ahead and calculate 1/2 times 176.63. Go ahead and do that now. And that answer is, the area that you need to cover is 88.315, which rounds then to 32. Okay, so now we have to read our question. So we have this much stage to cover. A gallon covers 75 square meters. Oops, that makes me forget that I forgot my label. When we do area, our label's meters over there. So we're going to label this meters squared because area measures squared. So go ahead and put that in. So the area of the stage I need to cover is 88.32 meters squared. Then I read the question. It says, oh, 1 gallon covers 75 meters squared. So is 1 gallon going to do it? The answer would be no. 1 gallon is not enough, so you would go ahead and you would buy 2 gallons. Then you would have plenty left over, right? Because 2 gallons would cover 150. Okay, on this next question, I'm just going to draw it out. I know you have it on your paper. Kind of looks like a Pac-Man thing. And then we have 4 meters here. Okay, so this is right on your second question. We are going to pretend that we are going to do the circumference of this. Let's pretend this is maybe some kind of garden, and you want to fence around it. So if we're going to go around this garden with a fence right here, then we're going to do that and that. We're going to figure out how much it is around, okay? So first thing, it starts with formula, of course. And anytime we go around, pi r squared sounds like area to me. When I need circumference, I use pi d. And remembering that that c is going around anyway, so that helps us remember that the c word is the one that goes around. Okay, we're going to substitute our numbers underneath that. Underneath the pi is 3.14. And we have to find the diameter of the circle. Well, first thing you should kind of know what it is, uh-oh, that's not a circle, right? So I'm going to just pretend that we're going to do a circle. So you can kind of see this circle we're going to do. All right, so if I wanted to find the diameter of this circle, like all of this going around, I need a diameter. Diameter goes all the way across. You can see this line right here is only going halfway. So to get the diameter, we need to double it because it's got to go all the way. So your diameter is going to be 8. So I want you to take that right now. Go ahead and calculate your 3.14 times 8. And your circumference around the whole circle ends up being 25.12. But you're not going all the way around it, are you? If you look, you're not going this distance. There's no curve there. So you have to think, what fraction of the circle are we needing here? What fraction did we cut out? Raise your hand if you know that. Hopefully you guys see that as 3/4. So 3/4 of the circle is what we need. So we're going to take our circumference of the whole circle and we're going to times that by 3/4 of it because we need 3/4 of that amount. Anytime you need 3/4 of something, it means 3/4 times that. So go ahead and calculate 25.12 times 3/4. And your answer should be 18.84. That is the curve right there. So we know the distance on the curve, which is the harder one to find, is 18.84. But I did say we were going to go all the way around this shape. So the curve is part of the shape, right? We also do the straight length and this straight length. Well, that's pretty easy to calculate, isn't it? What's this length? You can see it's a 4. What's this length? That also has to be a 4. What's 4 plus 4? Hopefully you know that is an 8. So the curve is 18.84. You're going to also add the straight lengths of 8 to get a total of 26.84. That's how much it is to go around this Pac-Man-like shape. Okay, now we are going to do some unusual shapes. These aren't just, your plain old Jane normal shapes. We're going to have to figure some things out. So when you look at this shape, and I'm going to say we're going to find the area of it. I didn't put what you have to write here, so you're going to have to remember to write these. So first of all, there is no formula for that shape. I don't even know what that shape's called, okay? But I can split it up. So what I can do is I can draw a line from here to here, okay? Now can you see the two shapes that I need? Hopefully you guys see that as a rectangle and a triangle. So remember how we always write our formulas? I'm going to insist you write your formulas. So formula, we're going to do rectangle. Formula of rectangle. Who remembers how to do a formula of a rectangle? If you don't know, it's because you didn't write it enough last year. But raise your hand if you know it. Okay, or you can just look at the poster on the wall. It says formula of a rectangle, A equals base times height. So you're underneath your formula, underneath that formula, you always substitute your numbers. So if you look at your formula for your rectangle, your base and height. One thing about base and height that kids don't get is base and height have to be 90 degrees. That's in any shape you do. So if your formula talks about bases and heights, make sure you're looking at a 90-degree angle. So you can see this line right here and this line right here. Those are 90-degree angles, right? So we can say our base is 20 times our height is 10, and we probably can do that in our head. Our our rectangle is now 200. So I'm just going to write that inside here because it's going to remind me that, oh, the inside measurement is 200 meters squared for the rectangle. But now we need to do our triangle formula. So we're going to go ahead and write formula for the triangle. Who remembers what the area is for formula of a triangle? Again, if you don't know, it's because you didn't write it enough, right? You know that, hopefully you know, that it would take 2 triangles to make a rectangle, right? If I have one triangle here and one triangle here, see when you put them together, you get a triangle. So triangles are basically half of rectangles. So when you do your formula often is written 1/2 base times height, because your triangles are half of rectangles. That's how you can remember that. If you know your rectangle's base times height, your triangle's half of that. So I'm going to do your substitution. We can go ahead and write 1/2, or a lot of kids would rather write 0.5. It really doesn't matter. You want to type it in as 1/2 as a fraction, you can. If you want to say, I want to type it in as a decimal, we can do that too. 1/2 or 0.5 times. The base and height are very important that we get the right numbers, okay? We need to make sure we have the height and the base. So the 90-degree lines. So this one right here and this one. Now, indirectly, it tells us that. It doesn't specifically tell us what this number is. You can see that the entire distance is 20 here, way down here, and this distance is 12. So from here to here is 20, but here to here is 12. Does it make sense that we would subtract them. 20, take away 12. This would have to be an 8 because 12 and 8 has to be 20. So our base is going to be 8. And then our height here doesn't directly tell us that either. We know the whole measurement here is 21, and we know this measurement over here is 10. So from the top to the bottom is 21, and from here to here is 10. So obviously what we'd have to do is take the whole thing, take off that 10, which gets us an 11. So our height over here is an 11. So we write times 11. Go ahead and calculate that. 0.5 times 8 times 11. Hopefully you got 44. So our triangle inside is 44. We're not done yet. We have to do the whole shape. So at the end, we have to take the 200, the rectangle, combine it with the triangle, which is 244, or sorry, just 44. So you have a total of 244 meters squared. Okay, this one is quite tricky. So we want to find the area of the shaded ring. So it's like a donut, and we want to find the area of the donut. We don't have a formula for area of a donut. So what we have to do is get really creative. Hopefully you can see we have one really big circle. So if we take all of this, we can go find the area of everything. That's this donut stuff, and it's the stuff inside too. So literally I'm going to find the area of this donut and all this stuff too inside, okay? So formula for area of a circle. So we're going to go ahead and write our formula right here. Area of a circle, pi r squared. So we're doing the entire circle first. So I got pi r squared. We know pi, we put our number substitution underneath it, is 3.14 times. And we look at the whole circle here. Radius is halfway. You can see we gave that measurement to you, didn't we? We gave you that as an 8. So our radius is halfway, which is an 8, times, I have to do that twice, 8 again. Go ahead and calculate that, please. And hopefully you got 200.96. Okay, that is the entire circle. We don't want the whole circle. We want just the outer ring. So basically, we want to get rid of this middle white space. This is the stuff we want to get rid of. So do you see that as a smaller circle right now? So we're going to find the area of the smaller circle. So again, we write our formula. Area of a circle is pi r squared. So that's where we go first. Underneath the pi, we write 3.14. This is going to be your hardest step. We have to figure out what the radius of the circle is. So we have to be very creative here. So from here to here, we'll use a different color so you can see. From here to here is 8. But I want from here to here, because I only want the halfway of the middle circle. Well, I know the whole thing's 8, but then if you come over here and look, you can see this ring right here, that's 3. So that's this measurement right here. So this is 3. So if the whole thing's 8 and this is 3, now you should be able to tell me what this measurement is. Hopefully you know that I take the 8, I take off the 3, so my radius is now 5. So pi times 5 times 5. We have 2 radiuses that we multiply together. Go ahead and calculate that, please. 3.14 times 5 times 5. And you should be getting 78.5. That is also not our answer yet. Here's what we got no so far. This is the entire circle. We don't want that. This is the middle circle. We want to take the whole circle, the 200, and we want to get rid of this middle circle, this 78.5. So if we take the whole circle and get rid of that, does that make sense that we would subtract those? So you would take 200.96 and you would subtract 78.5. Your answer ends up being 122.46 meters squared. Okay, on this next one, we're going to do both things. We're going to find the distance around and the area inside. This is like when you play basketball. So this is your free throw line right here, your top of your circle, and your basket would be down here. So we're going to pretend we have a really mean coach and we got in a lot of trouble and they want us to run around this space. Not sure what they actually call that. And we want to find the distance around. So they make the whole team start right here. They want you to go all the way this way, and then they make us turn this way, and they make us go around the curve, they make us go straight and back, okay? So we got to find that distance. Well, obviously the hardest one to find is the curve. Pretty darn easy to find this distance. These straight distances, that will not be an issue. So let's figure out how do we do a curve. Well, we don't have formula for half of a circle. So we need to find all of the circle. So we're going to make this pretend circle here, and we are going to do circumference of a circle. When I need circumference, I use pi d. So first thing you do is write your formula, and then underneath your pi, you're going to write 3.14. These are shoved together, so you write times. And then you look at this circle, this beautiful little circle right here. Going distance across is all the way across, and somewhere on this diagram it shows me from here to here. Look around, look around, look around, look up. Oh, do you see that the distance from there to there is 8? So your diameter is 8. So go ahead and calculate that. So 3.14 times 8. And that answer is 25.12. That's if we went around the whole circle. But we're not. We're not going on this curve, are we? We're not going there at all. All we're doing is going half of that circle. So we need half of 25.12. Do you remember how to do that? Of in math means times. So go ahead and take half times 25.12. And that would be 12.55. Now we got the curve. But don't forget, we got to run the whole thing. So here's the curve, the 12.55, plus we have to add these straight sides. So this side is a 10, plus this side way up here is an 8, plus this side over here matches the other 10. So that's what we have to add up. So it's 12.55 plus 10 plus 8 plus 10. And that should be 40.55 meters, straight meters, because we're not going inside, we're not doing squares, we're just going around. Okay, this is the last one we're going to do. So we have to do the area. So we want to count up how many squares are inside. Well, you can see two shapes, I'm hoping. I hope you see this rectangle, right? And then I hope you see a half of a circle. Well, we know the one that's going to be the easiest is going to be our rectangle, but we still want a formula. So formula of a rectangle, I'm going to go ahead and write over here, A equals, what's the formula of a rectangle? Hopefully you have that memorized, base times height. And then we're just going to put our numbers in. Our numbers are 8 times 10. That doesn't matter the order, as long as we're making sure we're using that 90-degree angles, which it is, and 8 times 10 is 80. So a rectangle, super easy to find, it's 80 meters squared. Now we have to do a half of a circle. Well, we know we don't have a formula for half of a circle, but we do have a formula for circle. Pi r squared sounds like area to me. So that's going to be my formula for my whole circle. So underneath the pi, I write 3.14. Now I've got to be really smart. The whole circle, if I draw that, looks like this. The radius is only halfway, and the only number I know is from here to here is 8. But that isn't halfway across the circle, that's all the way across the circle. So does it make sense that my radius would only be 4? Because I have to do half of that. So, and then when I have r squared, I have to write it twice. So pi times 4 times 4. Go ahead and calculate that. Pi times 4 times 4. And that answer is 50.24. But we got to remember that is an entire circle. I'm not looking for an entire circle. I'm looking for half of it. So I need half of 50.24. Of in math means times. So go ahead and go half times that. And your answer is 25.12. So I put that over in my circle. So here's my half circle. Here's my rectangle. I need all of it though. So I'm going to take both of them and add them. If I add them, I get 105.12 meters squared. You would need that if you were going to like paint the inside of that, or yeah, that's probably all you would do on a gym floor. So, okay, so now I'm going to let you start your worksheet. However, there's some hard questions on it. So I took some of the hard questions and put them on a video and have that on your Google Classroom. So if you get stuck on any of these, just take a look at your Google Classroom. It'll say difficult questions on your sectors of circles worksheet, and I can help you talk through those. Have a great day.